Good morning, dear students. In the last class, we have started a new chapter. What is that chapter means already we know. Electrochemistry here. From that electrochemistry, how many marks we are getting means 8 marks we are getting here. Coming to the definition for electrochemistry. Electrochemistry means it is a branch of chemistry in which we are going to produce electrical energy from energy that is coming from spontaneous chemical reaction, that is spontaneous redox reaction. Due to that spontaneous redox reactions only, now we observe the generation or the production of electrical energy. Now that electrical energy is used for non-spontaneous chemical reactions. Okay, even we have discussed regarding the importance of electrochemistry here. What are the importance of electrochemistry means? By using this electrochemistry means by using this electrochemical methods, we can produce different types of the metals like sodium, magnesium, calcium, and compounds like NaOH, chlorine, chlorine, like that. And coming to the second point, batteries and fuel cells. In that we observe the conversion, that is chemical energy is converting into the electrical energy. Next, last point, that is this electrochemical methods are very important. This electrochemistry is very important when compared to that of the other branches. What is the reason for that one means? Because it is energy efficient and less polluting. Next, coming to the fourth point, that is mostly transmission of signals in our body from cell to cell or cell to brain, brain to cell. All these are due to the sodium potassium pump here. Now they are playing a key role here for the transmission of signals here. Now this is the best example for the electrical origin. Okay, that's why this electrochemistry is interdisciplinary in nature. It means it is interrelated with the other branches also. Okay, right. This is regarding the importance of electrochemistry. Okay, right. Next topic is, what is the next topic means? That is cells here. If you take that cells based on this conversions, now they are classified into two types. What are their names? First one is electrochemical cells and next one is electrolytic cells. Okay, what are they? Electrolytic cells and second one is electrochemical cells. First, coming to the electrolytic cells. Now, if we take that electrolytic cells in that electrolytic cells, okay, we observe the conversion here. Which type of conversions are observed here means electrical energy is converted into the chemical energy. Okay, so in electrolytic cells, what happens here? I'll write that point now. Electrolytic cells. Electrolytic cells. What are these electrolytic cells means? Electrolytic cells means the cells in which electrical energy is converting into chemical energy. Okay, so electrolytic cells, if we take that electrolytic cells, in electrolytic cells we observe the conversion here. Which type of conversion we are observing means, this is the point you have to remember. Electrical energy is converting into the chemical energy. Right, next, coming to the electrochemical cells. Now, if you take electrochemical cells, if you take electrochemical cell, now in that electrochemical cells, what happens, opposite to this one means reverse. It means in electrochemical cells, okay, now we observe the conversion here. Which type of conversion means chemical energy is converting into electrical energy. Okay, in electrochemical cells what happens So chemical energy is converting into the electrical energy. So this is the main difference you have to remember between electrolytic cells and electrochemical cells. Tell me I will repeat once again. What are electrolytic cells? Electrolytic cells means these are the cells are the devices in which we observe the conversion of electrical energy into chemical energy. Okay, the cells in which we observe the conversion of electrical energy into chemical energy, they are called as electrolytic cells. Okay, right. Next, coming to the next one. What are electrochemical cells means? The cells are the device in which we observe the conversion of chemical energy into electrical energy. They are called as electrochemical cells. They are called as electrochemical cells. Now, best examples for this electrochemical cell means I will tell you the examples. That is galvanic cell, or it is also known as voltaic cell. Galvanic cell or voltaic cell. So this is the best example for the electrochemical cell. Okay. So if you take that, why sir these electrochemical cells are called as galvanic cell or voltaic cell means because this was first invented or discovered by the Galvanic and Volta. Okay. So I'll write that point. So this cells are invented by Galvanic and Volta. So due to that reason only, okay, now these cells are known as galvanic cell or voltaic cell. They are called as galvanic cells or voltaic cells. Now galvanic or voltaic cells are the best examples for the which type of cells? They are the examples for the electrochemical cells. What are electrochemical cells? Electrochemical cells means so the device or the cell in which we observe the conversion of chemical energy into electrical energy. Okay, right. Now here. So next we will discuss regarding the, if you take that galvanic cell or voltaic cell, or it is also known as, okay, Daniel cell. It is also known as Daniel cell. Okay. Now I will give you some information regarding that. So which type of means mechanism and function. What is the function or the mechanism that is involved in this Daniel cell, or it is also called as voltaic cell or galvanic cell. We will discuss the points later. Before that, I will give you some points. Some important point I will tell you. What are the names? Actually, if you take this conversion, chemical energy is converting into the electrical energy here. At that time, now here how we can produce that electrical energy means in that we are taking two containers here, or cells we are taking here, containers we are taking. In that containers we are placing electrodes here. Sir, you are telling that now in that cells we are placing the electrodes, sir. What are electrodes are means? I will give you some information regarding this electrodes. Okay, right. Now coming to that one. Now here electrodes, we will discuss regarding this one. Electrodes are of two types. Electrodes are of two types. What are the names? First one is anode. What is the first one? First one is anode. Next. Coming to the second one, that is cathode. Okay. If you take that electrodes, electrodes how many types? Electrodes are of two types. What are the names? First one is anode and the second one is cathode. Now coming to this signs. What about the sign of anode and cathode? Most of them are getting confusion here. Okay, I will tell you one shortcut here. Okay, what is that shortcut? Which type of signs are involved for this anode and cathode? Okay, those points I will tell you. Okay, now coming to this anode. What about the charge of or sign of this anode means? The sign of anode means it carries positive sign. It carries the positive sign. Anode carries the which type of sign or charge? It carries the positive sign. How we can remember that one means? What is the shortcut for this one means? Now see there. Add in mathematics already we know. Addition means nothing but it is indicated by the plus sign only, na? Like that. Add. That's why. What is the charge of anode, ma? The charge of anode is plus. The charge of anode is plus. Next, coming to the next one. Now, if we take the cathode, what about the sign? SIGN, sign or charge of cathode means opposite to this one. What is the charge of cathode? It is negative sign. Okay, right. Next point. Now here in case now we are taking a solution here. In that we observe the presence of anions and cations are there. It means now see there. Here I will write negative sign is there and positive sign is there. Now tell me now. And now my question is this negative charge. My question is this negative charge move towards the which electrode? That is my question. This negative charge, that negative charge move towards the which electrode? That is my question. Then what is the answer for that one? Already we know. Always negative sign move towards the which one, ma? It move towards the positive side. Why it move towards the positive side? Because already we know. Best example for that one is if you take the magnet. Now magnet is having the north pole and south pole here. Whenever north pole and north pole come closer to each other, at that time what happens now? Whether we observe the attractions or repulsion. Already we know. Same poles means repulsions. Opposite poles means attraction. Same poles means repulsion. Opposite poles means attraction. Like that here also. Now whenever this negative sign move towards the which electrode means obviously the answer is the negative charge. It moved towards the anode. Why it moved towards the anode means signs. See that signs now. Positive sign and negative sign. We observe the attraction here. Sir, one doubt arises here. Sir, what happens, sir, if that negative sign move towards the negative sign means that is cathode means at that time what happens? Both are carrying the negative sign only, na? Due to that reason only we observe the repulsion. We observe the repulsion. So that's why always we observe the attractions between the positive sign and the negative sign. So that's why this negative sign move towards the anode. That's why now if you take this negative sign. Okay, now it is indicated by means now it is known as nothing but anion. Next, what about the positive sign means it is cation. Okay, it means finally I will tell you one conclusion here. What is that conclusion means? Always anions move towards the anode. What is the point I told you? Anions move towards the anode. Next, coming to that. So what is the shortcut here? You have to remember means A. What are the first letters here? What is the first letter in anode? A. What is the first letter in anion? A. Means anions move towards the anode. What is the charge of anion? Negative charge. But what about the charge of anode? Positive charge. Don't confuse here. What is the charge of anode? Positive charge. What about the charge of anion? Negative charge. Okay. That's why anion move towards the anode. Next, coming to the next one. Cathode. What is the first letter here? C. Now coming to the cation. What is the first letter? C. Means what is the meaning of this one? Cations move towards the which electrodes means then the answer is cations move towards the cation. Cations move towards the cathode. Okay na? So this charges are you have to remember. That's why just you remember the first one, that is anode. Okay, what is the charge of anode means? The charge of anode is positive. What is the shortcut here? Add is there na? AD. Add means in mathematics addition means it is indicated by the positive. That's why anode carries the which type of sign means positive. Okay na? Right. What about the cathode? Cathode carries the negative charge. Okay. Now see there. Now here negative charge is there. Negative charge means nothing but anion. Anions move towards the which electrodes? Anions move towards the anode. towards the cathode. Okay, now let us take one example for explaining this concept. Okay, right. Now this is the example I am taking. Now I am taking NaCl. I am taking. What is the compound I have given for you? That is NaCl I have given you. Now see there, if we take that NaCl, already we know NaCl is the best example for the strong electrolyte. It is the example for the strong electrolyte. Sir, why it is the best example for the strong electrolyte means? Because it is undergoing ionization easily without using any external condition. Okay, on its own. Now it is undergoing the ionization. Okay, why? Because here we observe the which type of bond between the sodium and chlorine means it is a ionic bond. So due to that reason only, now they are going to produce which type of ions means. Now they are going to produce Na plus and Cl minus. Na plus and Cl minus are produced. Now see there, here I will ask you one question here. If it is the NaCl, now we know NaCl is undergoing ionization or dissociation. So due to that ionization, now here we observe the formation of the two types of ions. Okay, one carries the positive charge and another one carries the negative charge. Now my question is, if we consider the Na plus move towards the which electrode? Na plus move towards the which electrode? Then the answer is what is the answer for that one? Already we know. Now tell me, Na is carrying the which type of charge? Positive charge. Positive charge means, now tell me, whether it move towards the anode or cathode. Then the answer is, now Na plus carries the positive charge here. So due to that reason only, now it moved towards the cathode. It moved towards the cathode. Why Na plus move towards the cathode means? Because here Na carries the positive charge and cathode carries, already we know it carries the negative charge. That's why this Na plus move towards the cathode. Okay, right. Next, coming to the Cl minus. Now one more question. What happens if this Na plus move towards the anode? At that time we observe the repulsion. Why we observe the repulsions here? Because both anode and this Na carries the positive charge here. So due to that reason only we observe the repulsions. So that's why if Na plus move towards the anode, we observe the repulsion. But whenever this Na plus move towards the cathode, at that time we observe the attractions. Okay na? Right. Next, coming to the Cl minus. Now tell me the answer for this one. Cl minus chloride ion move towards the which electrodes? Then the answer is this Cl minus move towards the anode. Why? Because now it carries the negative charge. That's why. Now tell me. Now Na plus is, now it is acting as a cation or anion. Now Na plus is cation. And what about the Cl minus one? Cl minus is anion. That's why anion move towards the anode and cation move towards the cathode. Okay, now this is the mechanism that is you have to remember. It means now here if you want to prepare different types of the metals, at that time we are taking the different types of the starting materials we are taking here. At that time what happens, now they are undergoing the dissociation here. So due to that dissociation only, now we observe the formation of the ions here. Now what is the point here you have to remember means, whatever the ions that are formed during the course of the reaction, now they are transferring or they are transferring towards the which electrodes? That one you have to remember. If they carry the positive charge, then they move towards the cathode. If they carry the negative charge, then they move towards the anode. If you remember this concept, so we can easily produce different types of the compounds here. One topic is there, electrolysis. In that electrolysis, we will discuss some examples. Okay, right. So this is regarding, that is, so in electrochemical cells or electrolytic cells, mostly we are using the electrodes here. Which type of electrodes we are using means, two types of electrodes we are using. What are the names? One is anode and the another one is cathode. Okay, what are the points here you have to remember means, anode carries the which type of charge, cathode carries the which type of charge, and anion carries the which type of charge, and cation carries the which type of charge. Okay na? Right. So this is regarding the electrodes. Right. Now here next topic is now very important topic, that is we are going to discuss regarding the electrochemical cells. Electrochemical cells. Now here, if we take this electrochemical cells, already we know what are the best examples for this electrochemical cells means. First one is galvanic cell, or it is also called as voltaic cell. Okay, or even it is also known as Daniel cell. Mostly in the place of this galvanic and voltaic cell means best Daniel cell is the best example for the which type of cell means Daniel cell is example for the galvanic cell. Galvanic cell is example for the which type of cell means electrochemical cell. What are electrochemical cells means? The cells in which we observe the conversion here, that is chemical energy is converting into the electrical energy. Okay, electrochemical cells means they are one of the important types of the devices. These are the devices in which we are going to observe conversion of chemical energy into electrical energy. Chemical energy means there we observe the involvement of redox reactions. Due to that redox reactions only, now that chemical energy is converting into the electrical energy. Okay, now in this class we are going to discuss regarding the Daniels. Okay, right now one more point, this is the point you have to remember. If they are the electrolytic cells, at that time anode and cathode, okay, they carry the positive sign and negative sign. Cathode carries the negative sign. But coming to this electrochemical cells, this is the most of the students, most of them are getting confusion here. If it is the electrochemical cell, I'll write that part. If it is the electrochemical cell, okay, at that time, okay. Now, what about the charge of anode means? Anode carries the negative sign. In electrochemical cells, anode carries the which type of sign? Negative sign. Okay. Next, coming to the cathode. If we take the cathode here, cathode carries the which type of sign here means positive sign. Anode carries the which type of sign? Negative sign. And cathode carries the which type of sign means positive sign. I will tell you the reason for that one. Sir, if you take that, now you are telling sir, in electrochemical cells, anode carries the negative sign and cathode carries the positive sign here. Sir, why they are carrying such type of signs? Is there any particular reason for that one means? I will give you the clarification for that doubt. Okay. So, what is the point you have to remember here? In electrochemical cells, always anode carries the which type of sign means negative sign, and cathode carries the which type of sign means positive sign. Okay. Right. I will give you the explanation for that. Okay na? Right ma. Now coming to this one ma. Now I will explain this Daniel cell ma. Okay. Now you know ma. So what are the points here we have discussed ma? Now based on this conversion, now these cells are converting into the these cells are classified into the two types ma. What are the names? First one is electrolytic cell and second one is electrochemical cell. What is the meaning of electrolytic cell means? In electrolytic cells we observe the conversion of electrical energy into chemical energy. Next, coming to the second one, if we take that electrochemical cells, in electrochemical cells we observe the conversion of chemical energy into electrical energy. Best example for this electrochemical cells means galvanic cell or voltaic cell is the best example. Why this electrochemical cell is called as galvanic cell or voltaic cell means because this cell was first discovered or invented by the galvanic and Volta. So due to that reason only they are called as galvanic cell or voltaic cell. They are the best examples for the electrochemical cells. Now it is modified with the Daniel cell. Now we are going to discuss regarding the function, that is construction and function of this Daniel cell. Construction and function of this Daniel cell. Okay. Right. Now one more point, normal cells, electrodes carries the which type of charge? Anode carries the positive charge and cathode carries the negative charge. But coming to this electrochemical cells, always in electrochemical cells, this point you have to remember, only in electrochemical cells anode carries the negative sign and cathode carries the positive sign. Okay, right. Now here, coming to this reactions now. Right. Now, in electrochemical cells, now we are taking the two types of containers like this. Containers we are taking one. Okay. Now here we are placing, we are taking two types of electrodes here. Now this is the zinc rod we are taking. The zinc rod is dipped in zinc sulfate solution. And here one more electrode we are taking here. Copper rod we are taking. Copper rod, this one. Copper Cu. Copper rod we are taking. Copper rod is dipped in copper sulfate solution. Okay. Now here we are taking two containers here. Two containers we are taking. In that two containers are vessels. We are taking a zinc sulfate solution. In one vessel we are taking zinc sulfate solution. In another vessel we are taking the copper sulfate solution. Now what we are doing here? Zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. Okay, na? Right. Now they are connected through the wire. They are connected through the wire. Okay, right. Next point. Now here we are using one salt bridge. Now this is the salt bridge. Okay. Now here we are, I will tell you sir, why we are using this salt bridge. There is a reason for that one. I will tell you later. Just you remember. Now here we are using the salt bridge. So now this is the construction function of this Daniel cell. Construction and function of Daniel cell. Okay. In Daniel cell, what we are doing, now we are taking two vessels or containers here. In one vessel we are taking the zinc sulfate solution. In another vessel we are taking the copper sulfate solution. We are taking. Now zinc rod is dipped in zinc sulfate solution and copper rod is dipped in copper sulfate solution. Now they are connected through the wires. Even we are using the salt bridge here. Now sir, now you are telling sir, two electrodes are we are using sir. Now which one is acting as a anode and which one is acting as a cathode? Means now in case if you take this zinc rod, okay, now it is acting as anode. It is acting as a anode. Now coming to this copper rod. This copper rod is acting as a cathode. Copper rod is acting as a cathode and zinc is acting as a anode. Sir, why this zinc rod is acting as a anode, sir? Means I will tell you two reasons. Okay, coming to the first one. Whenever they are placed, we are dipped this zinc rod in zinc sulfate solution. Whenever this zinc rod is placed in zinc sulfate solution, at that time what happens? Slowly this zinc rod dissolves in zinc sulfate solution. Okay, zinc rod dissolves in zinc sulfate solution. Okay, so due to that reason what happens? I'll write that point. Zn is converting into Zn2 plus. Now see there, is there any difference? Yes, of course there is a difference here. Now it does not carry any type of the charge here, but it carries the charge here. Now see here, Zn is converting into Zn2 plus. Means nothing but now loss of electrons. Loss of electrons means oxidation. Okay. Here Zn is converting into Zn2 plus. Means loss of electron. That's why Zn2 plus is formed. Means oxidation. Oxidation means loss of electrons is known as oxidation. Now due to the loss of electron means now whatever the electrons are lost to, now they are surrounding this zinc rod. Now see, electrons are there. Electrons. From where these electrons are coming from? These electrons are coming from where? These electrons are coming from this zinc rod. Now, whatever the electrons are released during the course of the reaction, now they are surrounding this rod. They are present around this rod. So, due to that reason only, now this pole, if you consider this pole, okay, now it is known as negative pole. Why it is called as negative pole? Because now this rod is surrounded by the more number of electrons. What about the charge of electron? The charge of electron is negative charge. Already we know the charge of electron. The charge of electron is negative. So due to that reason only, okay, now these electrons are surrounding this pole, and so due to that reason only, in electrochemical cells, if you take that anode, okay, what about the charge of the anode means it is indicated by the negative sign. Why it is indicated by the negative sign? Because the reason for that one is whenever this zinc rod is dipped in zinc sulfate solution, at that time what happens? Zn is converted into the Zn2 plus. It means loss of electron. Now that electrons enters where? Now the electrons are surrounding this zinc rod only. That's why negative charge is developed around this pole. So due to that reason only, now this anode is indicated by the which sign means negative sign. Okay, right. Next, coming to this one. Now here what happens, now whatever the electrons that are produced here, now they are transferred from here to here. Now the electrons transfer from here to here. Okay. Now here what happens, copper sulfate solution is there now in that copper sulfate solution, now we are placing the copper. At that time, now if you take this CuSO4 now here this conversion you have to remember. Cu2 plus is converted into C. Now see there. What is the difference here? The previous case, Zn is converting into the Zn2. But coming to this one, Cu2 plus is converting to C. Cu2 plus is converting to the Cu. It means gain of electrons. Gain of electrons means reduction. Sir, now one doubt arises for you. Sir, gain of electrons is reduction, sir. So from where we are getting that electrons means, now the electrons are released here now the electrons are going to transfer from this zinc rod to copper rod. Now whatever the electrons are transferred here, now that electrons are abstracted by this CuSO. Already we know. If you take the copper sulfate, okay, now it is undergoing dissociation here. Due to that reason only, Cu2 plus and SO4 2 minus ions are formed here. Now that Cu2 plus, here I have written that Cu2 plus ions, now they gain that electrons which are coming from this one. Okay, by the gain of that electrons, Cu is formed, copper is formed. Now see there. Now here we observe the reduction. So it means so that's why gain of electrons here. So here what happens, now it means gain of electrons. Whenever this Cu2 plus gains electrons, at that time what happens, now this copper is there this copper, that is going to deposit here. Now here it is going to be deposited here on the surface of the copper and surface of the copper. Now this Cu2 plus is going to be deposited. Now here towards the copper, which ions are moving? Cu2 plus ions are moving That's why here positive charge is present around this pole. So due to that reason only, what about the charge of this cathode here means positive sign. Okay, so why it carries the positive sign means, now see there, Cu, what about the charge here? Cu2 plus ions move towards the copper rod, and that copper is going to be deposited on that Cu2 plus ions which are coming from CuSO4. Now that Cu2 plus ions move towards the copper. Okay, now they are going to gain electrons which are coming from this one, and that Cu2 plus is converting to Cu. Means Cu2 plus is converting to Cu means whatever the Cu2 plus ions are there, now they are going to deposited on the surface of this electrode like this. Okay, so that's why now what happens here, around this pole positive charge is there na, Cu2 plus means what about the charge here? Plus charge. So due to that reason only, cathode carries the which type of charge here means positive sign. They are going to carry the which type of charge means positive sign. Okay, this is the explanation for why in electrochemical cells, anode carries the negative sign and cathode carries the positive sign. What is the reason for that one? Now we know. I will tell you once again. I will repeat once again. Now here anode carries the negative sign. What is the reason for that one means? Because whenever zinc rod is dipped in zinc sulfate solution, whenever zinc rod is dipped in zinc sulfate solution, now that zinc rod is slowly dissolved in this zinc sulfate solution. At that time, Zn is converting into the Zn2 plus. Zn is converting into the Zn2 plus. Now this is called as oxidation. Why it is called as oxidation means because loss of electrons are observed. Loss of electrons means oxidation. Now whatever the electrons that are released, lost during the course of the reaction, now they are present. Now they are present around this zinc rod. Electrons are there. Now if we take this pole, now this pole carries the which type of charge means negative charge. Why it carries the negative charge means because if you take that electrons now, what is the charge of electrons? Negative charge. Now these electrons are present around this zinc rod. That's why this pole carries the negative charge. Due to that reason only, now here in electrochemical cells, anode carries the which type of sign means negative sign. Okay, right. Next coming to the second one now. Copper rod is dipped in copper sulfate solution. At that time what happened? Now if you take the copper sulfate solution, now it is undergoing dissociation here. That's why Cu2 plus ions are formed here. Now Cu2 plus is converting into Cu. Nothing but gain of electrons here. Gain of, sir, doubt arises here. From where they are getting that electrons means, now here the electrons are generated. Now that electrons are transferred from anode to cathode, that is zinc to copper. Now the electrons are abstracted, gained by this copper. That's why that Cu2 plus ion is converting to Cu. Now see there, this Cu2 plus ion is moving towards this copper. What about the charge of Cu? Positive charge. That's why cathode carries the which type of charge, which means now it is surrounded by the cations, that is positive charge ion. That's why here cathode. It is acting as, it carries the which type of sign means positive sign. Right. That's why in electrochemical cells, always anode carries the negative sign and cathode carries the positive sign. Right. In the next class, we will discuss regarding function, how to construction. Now we have discussed which type of conversions we are observing in this Daniel cell. Next class we will continue. Right. Thank you. Tomorrow I will continue.